is Dr. Haswan. So today I'll be doing my presentation for the statics. My full name is Sivaraj Ravi. My Matric ID is MH19079. So the topic I chose is finding the moment of inertia for the cross-sectional area, and then the question I took from the quiz 3 to finding the location of centroid. So I'll be continuing from there. Okay, so this is the question I took from quiz 3 to find the centroidal location of this whole cross-sectional area. So firstly, I've divided this whole shape into 5 specific shapes. One is this square over here, one rectangle over here, one small triangle which I've removed here, addition of another triangle here, and finally a circle that I removed. So this whole cross-section area I can divide into 5 shapes. And then if you notice that I have to find certain things in order to find the centroidal location. So the formula says I have to multiply with x wave with the area over the summation of area. So first, what is x wave and y wave? X wave and y wave is the centroidal location of x-axis and y-axis of a specific shape. For example, I took this rectangle over here. So this is the formula that I used to find the value of x wave. So now you notice that x wave is -3. So which means it is at -3 direction. So the centroidal of this shape along x-axis should be around here, and then for the y it should be at +4, so it should be around here. And then following that, after finding the area of each shapes, we can notice that there are negative sign in this area, whereas others have positive, and also the circle has a negative. This means that I am removing this whole area from the shape, so therefore I am having a negative symbol over here. So when I multiply this with a specific axis, and then finally submitting all of the values and then inputting in this formula, I can find x bar and y bar, which means that this is the location of this whole cross-sectional area. So if you notice that the x says 3 and then y says 4, so it should be around here. Okay, so now from this I can find the moment of inertia. So what is moment of inertia? Moment of inertia is the amount of energy that are required to twist or bend the whole cross-sectional area. So along a certain axis, actually we can use centroidal x and y axis using this method. Okay, and then we can also find the moment of inertia at x and y axis. So for the centroidal one, we have to find ix and iy. This I bar is actually given in the formula from appendix, so we just have to follow from that. And then using the formula there, we have to make sure that for the part that we are removing, we must put a negative symbol. Okay, so for all I, we have to put negative symbol. For the part that we are adding, there is no need to put an addition. And for the finding the area multiplying with y bar minus y wave, also I am using the area which I used to negative to input over here. Therefore, I don't need to add another negative to symbolize that I'm removing this area. Just use once. Now, why do I use y bar minus y wave? Y bar is the location of the centroidal of this cross-sectional area, and then y wave is the location of centroidal of each shape. So therefore, this means that it is symbolizing a distance multiplying with the area of the shape. Therefore, after we finding this for ay and ax, we finally have to addition. Here is the tricky part. For the ix, we have to add with the area of this difference between y. For the iy, we have to addition with x. Therefore, for the final answer, we have to summation of whole this thing and this thing to find the solution of centroid x and y. For the centroidal of just x and x axis without the centroidal, we don't have to minus the y axis with the centroidal point. So we can just skip this step, directly move with the shapes only. So from here also we can find the answer. We just have to be careful with ix and y and iy with x. That's also. Thank you.